Hello and good morning, everybody. I welcome, first of all, our virtual participants from all over the world. We just started our Zoom meeting. I hope everybody virtually can hear us. And then I welcome all the in-person participants. And it's great to see everybody in 3D after 2 years of no conferences. A lot of people in this room I have seen in the last 2 years a few times at some competitions, but most of you I've never seen before, and I hope that we can chat in the next couple of days, and I'm very excited that you're here and visiting our workshop, our second workshop on opportunities and challenges with autonomous racing. So, and now everybody's reading racing and second. That's not matching together, right? Because in racing, we want to be first. But in this case, second means something very, very good because our inaugural workshop last year was a great success. So we, as the organizers, decided to do another workshop this year again. My name is Johannes Betz. I'm from the University of Pennsylvania, and I'm co-organizing this workshop, first of all, with Madhur Behl, which you see here in the front, with Rahul Mangharm, who's currently in line, I think, and getting his ticket, and with Venkat Krovi in the back. Thanks, Venkat, for being here today. And first of all, we have to say thank you to the IRS Autonomous Ground Vehicles and Intelligent Transportation Systems Group, which supported us in this workshop and gave us ideas on how to move on with the topics. I just want to use a few minutes to introduce you to the field of autonomous racing, because every time I discuss this topic, I get the question, why racing? So I myself, I'm a big fan of Formula One, and probably like a lot of people here in this room watching motorsports. And when I watch Formula One, I see three topics. First of all, it's about detecting the vehicle limits. You see here the car driving in the rain, because every time we go to a new racetrack, the condition changes. We have conditions changing in the weather, we have conditions changing in the racetrack layout is different, which means the car setup is different, mainly low downforce, high downforce. Number two is decision-making at the limits. And what you see here in the middle is an overtaking maneuver at Spa-Francorchamps in a Formula One car at around 270 kilometers an hour. So the driver decided it's a good idea to do an overtaking maneuver here in this left-right turn, which is a very bold move. So you see the high prediction uncertainty in the Formula One car. You see strategy needs to be taken into account, because afterwards a long straight is happening. Is the other car overtaking me again? Is this a good decision? You need to take care of energy and finally make the decision of the overtaker. Number three is handling at the limits. You see in the last image, Michael Schumacher driving in Monaco, which is one of the most difficult racetracks because it's narrow. One control error here and the car is crashing into the wall, and you see the car sliding a little bit. So high speeds, high accelerations, high planning horizons are necessary, and finally, small reaction times. Now combine everything you see here and say, let's do that autonomously. And that's why we are here, and that's what we can learn from this topic. When we look at autonomous racing itself, we see a lot is happening in R&D. And when I looked at all the papers that are around there in the last 12 years, we see over 270 scientific papers published, peer-reviewed, published papers. And just look at the number at 2022. The number is at 33 papers right now, and we are not even in the half of the year. So there's still 6 or 7 months left to increase that number, and you see the numbers are going up. Well, you also see that a lot of people focusing on control and planning, like half of the papers are in this field, which is fine and totally understandable, because that's where the magic of the autonomous race car is happening. We see a little bit in perception, and we also see a lot of real-world testing and hardware. And if you look at these numbers, that gives us the confidence to say this workshop is a good idea, and this is a problem. Autonomous racing is a problem which we want to pursue further and research more further. The second thing I figured out is the amount of hardware in the scene. So on the left side, you see F110s, it's coming from Japan. We have a race today, small cars that competing against each other. It's mostly for student researchers, it's mostly for student teams, but it gives you a low-cost platform for doing some racing. And then you see reduced scale. Formula Student is a big community, like all technical universities in the world have one of these teams and one of these cars. It's amazing what they achieve. And we have a presentation from one of the winning teams today. Then we have the EV Autonomous Grand Prix. It's a brand new competition that inaugurated last year and happened just a couple of days ago again. And those people say reduce scale on a go-kart, let's do that. And then there's the big league. RoboRace is one of the big companies. We have an invited speaker today who was a former CTO. And we have the Indy Autonomous Challenge, where Madhur took part, where many of you who are listening today took part, which was a big success, single vehicle, multi-vehicle. So you have all this hardware out there, you can use it and make your cars run fast. And this setup gives me the confidence to say we are pursuing a lot in the field of autonomous racing. That's why we're here today, and that's why we invited you to the second workshop on autonomous racing. I welcome everybody to this workshop. We start now with an invited speaker session and then move on to a contributed paper session, invited speaker session, to a lunch break. Repeat that again to contributed paper session because we have a lot of students contributed some papers. Invited speaker session number 3, contributed paper session 3, and then we're closing at around 5 p.m. That's from my side. If you don't have any questions, I would now like to introduce our invited speakers. And we have Mauro Salazar from TU Eindhoven, Brim Balcom from Oxbotica, Srikant Sipali from Texas A&M University.